name's Kevin Bruce at Roslin Cell Sciences, and our role was, well, my role as Work Package 2 leader was to run the central operations for the bank, so that's bringing all the cell lines in, processing them, performing the QC, banking them ready for distribution. So we're going to talk a bit today about the challenges we faced, and there are already a lot of synergies with what Mark's talked about in terms of STEM Bank. But I think as well, Andreas, you touched on this earlier, which is that in the main, a lot of IPSC lines were being made and still are in this way, which is really within the bounds of a specific research group's aims, and quite often using very different methods for generation of the IPSCs and culture of these IPSCs, variable testing, make enough vials for my research project, job done. So the idea with EBiSC was to enable access to a larger and more diverse set that have been banked in a standardized manner. And so with EBiSC then, the main role is to take a variety, you have a large variety of IPSCs being made in a lot of different ways, put those through a central facility where they're banked in a standardized way, all undergo the same quality control testing, and then deliver one more standardized or multiple standardized products to multiple users at the other end. So standardized operational processes are central to all that, of course. Everything needed to be standardized, and we had a lot of workshops and effort at the start within the project itself to try and harmonize the activities that each of the partners had. And then this graphic here, I think, details the main components of the central operations, so procurement of IPSCs. So one of the things that was not in the call for the project actually at the start was to make new IPSCs. It was all about pulling in existing IPSCs that were out there and providing those in a standardized way. But actually that changed within the project, and we did commission a whole load of new lines. But this was mainly initially procurement around procuring existing IPSCs rather than new primary cells from donors, all the banking, and then the distribution. So I'm going to just talk today in a simplified way about some of the key challenge areas that we had around the biosample acquisition and the legals, the cell processing, the QC testing, and then storage and distribution. So this is something that's already come up quite a lot this morning in the talks already, which is consent, ethics and consent. And it's something that probably actually was one of the major challenges for this project. If you imagine multiple cell lines coming from all over Europe, they've already been made from biosamples which have been procured years before. And what we had to do was ensure that cell lines coming into the bank could be provided and distributed in a way that was consistent with ethics and consent that would be required for freedom to operate that the pharma companies and everybody else needed. So that was a real challenge, because the first thing you've got to do is you've got to get hold of the consent form that the donor actually saw. And like I said, that could have been years before. So you talk to the person who's depositing the cell line, and they say, oh, I've never heard of a consent form, you'll have to talk to my PI. So you talk to the PI, he's may have it, or it may be with a clinician, and then the clinician is very busy, of course, and so he says, we'll talk to the other person in the clinical team, and then they left years before, and it's another new person, and by the time you get the form, some months have passed, and then you get it, and it's in Spanish or German or Italian or what have you. And then, of course, so what we had to then do was decide what our standards were for consent. Did you have consent to generate IPS to start with? Did you have consent to do any genetic testing on that sample? Could you distribute these cells worldwide and share them with others, et cetera, and compare that to the actual consent that was obtained, and then take a judgment as to whether or not that was suitable. And we've had consent forms that were 1 page long, 10 pages long. So this really was a big quagmire for us to get through. But we did that, and within EBiSC, we've created a set of IPSC relevant patient information and consent forms. You can download them off the website, and those were developed along with Work Package 4, and they cover all these and items that I've mentioned and more. So one thing I do is encourage you to go and use those templates. They have been translated into 1 or 2 other languages as well, and they're available. There's also, I've referenced this paper here, which is, I think, a very good read, which looks at how to enable IPS generation from pre-existing biosamples. Okay, so the next step is then you need to have some kind of legal structure for depositing the cell lines into the bank, so handing them from one entity to the other, and it's a very similar set of problems in that, so what you need to do is the owner of the cell line needs to be able to sign a legal document. And I've underlined the word ownership because actually for many of the cell lines that people were looking to deposit in the bank, when you asked the question, who owns this cell line, nobody knew. So they'd never thought about that. The cell lines had been generated using funding from multiple sources. They may have been made from primary cells that had been transferred under material transfer agreements, and so they'd never thought about actually who owns the cell line, who has the rights to deposit this in the bank. So that was one of the issues. And then you end up having to talk to multiple tech transfer officers who'd never heard of an IPS cell line before. And then to touch on what Andreas was saying, once they do realize that they own something, they're all interested in what royalties they can get if you use the cell line and discover something in the future. So that's another set of issues. So that was really, to tackle that, we really had to be able to communicate the benefits of sharing these cell lines and have clear and open discussions and help people to understand what EBiSC was about. And really it was all about communication in the end. So along with that is gathering the data that comes with these cell lines. So everything from donor information, what was the sex of the donor, what was the diagnosed disease, could we get more information because that would be valuable around age of onset, was there a clinical genetic diagnosis that we were able to get that information, what was the reprogramming method, and what QC had been done on the iPSC line. And of course those are all sound like easy things to ask, but then actually you're relying on somebody gathering that information and providing it to you, and then you receive the information and it's in emails, it's in Word documents, in Excel, and all that has to be consolidated and put into the data system so that we can understand and transfer that data to the user, so that because there are implications around IP with reprogramming methods, etc. So we were quite lucky in that we had Charité within the consortium. We were able to build on the HIPS-Reg European Registry, which was a pre-existing database for pluripotent stem cell lines, which helped us to consolidate a lot of this data and manage it at our end. Okay, so in terms of cell line processing, one of the biggest hurdles we faced was this issue of multiple different centres providing us iPSCs that had been cultured in different conditions and trying to standardise that. So what approach would we take to cells that were being cultured in different medias, different matrices, coming to us frozen in different formats, passaged in different ways, how to, the challenges with adopting them into new conditions. So one of the approaches we took within the project was to develop this hot start approach, and there's a publication that we've had out, I think I've got it referenced later, describing that experience. And so this was 8 centres within the project in UK, Netherlands, Germany and Denmark, who all provided iPSCs. So what we did was had workshops at the start and training to encourage them to adapt standardized processes so that at least many of the foundational collection lines came in a standardized way. And then it was all about using standardized protocols and standardized approaches and relying on the skills of the TC teams to adapt into those new conditions and monitor for changes. And of course we had strict quarantine conditions at the central facility, making sure that we understood the performance of the lines as they came in, and also that they were free of any other microbiology you didn't want in there. So this slide here, if you look at it, shows you some of the main issues that cropped up. If you look at the N numbers on the left, they're quite small. We're talking 30, 40 odd lines, and this is really from the hot start collection. But you can see that all cells recovered, but we had some varying issues. Morphology was highly variable, and we had some morphologies which actually we thought there's something very wrong here, but then by all other QC characterization criteria, they actually passed. Some differentiation that you'd expect, especially when you're moving from one culture condition to the other. Issues with fungal contamination. Actually, I thought that number was quite a low percentage, given that many of the cell lines that we were receiving had been grown in antibiotic conditions as well. We did have some human viral pathogens detected in sample. No mycoplasma, which I thought was a really good result to get. But we had some identity issues as well. So we had cell line sent as a female cell line, ended up being male. We had a vial where we test for identity. We discover there's more than one cell line in there. But I think that's all validation, good validation of the QC that we applied. So as well as having the variation in culture conditions and reprogramming, etc., there's also just a large number of cell lines. So I think at the central facility now processed approaching 500 lines, and there's a certain amount of complexity that comes with just managing that and scheduling that work. There's a lot of variability in when you expect to receive cell lines and when they actually turn up, and then when you thaw them, you might thaw 10 lines at once, and some go off like racehorses and others go off like snails, and that all has an impact on the resources you have to actually process those cell lines. So managing that and managing the whole data set around that becomes quite a complicated affair. We'll talk a bit about data management in a second. But making sure that you can capture that data, understand it, and learn from it was one of the key things in the project to help schedule it better. And I'm sure we've all used complicated spreadsheets in our time, but there was a lot of them in this project. So data management, that was one of the other key things that we had to tackle, and we had work package 7, which was dedicated to data management, and Peter's going to talk about that tomorrow. So we had, as I mentioned, lots of different types of data, from paper consent forms to data on existing cell lines, data we were generating ourselves, and all of this needed to be pulled together in a consistent way that could be shared between the different centres. And of course, need for standard terminology. So we had work package 7 led by EBiSC, and also we had frequent focus groups and communication. And one of the key things was also at the beginning of the project, just thinking about requirement specifications. What did we actually want? What did we need? Making sure that was clearly understood to develop the systems around those specs. So this is an overview of the data management system that we had. So the big box in the middle is showing all the different components that were required in the system, from depositor management to inventory systems and even e-commerce. And the 4 key components of this data management system, so the HIPS-Reg, which I've already mentioned already, sorry, I've not updated the slide, around the registry, EBiSC using the biosamples database and how to host the genetic data, the LIMS at the central facility, and then ECAC for the e-commerce system. And I'm going to pull out a few examples of areas that I guess were in some ways challenges, in some ways not, but actually were critical and really important, so worth keeping in. Often not the most exciting topics to talk about, but actually from talking about challenges for a large stem cell bank, these are actually critical. So nomenclature being one. Again, we benefited from the infrastructure at Charité that they already had with HIPS-Reg, but we had to consider whether this was appropriate for us, and nomenclature of cell lines is important, not just so that you can share them and understand and make sure that you've got traceability, but also once users use these cell lines and that data is published, we want to encourage them to use this kind of nomenclature so that it can be picked up by AI systems and detect publications that are using cell lines, and that all helps to feed back into the database. So this is how the system works. This is a Cologne line from University Cologne, and the components are a code for the depositor name, an I to indicate it's an iPSC line rather than an embryonic stem cell line, a code for the donor, a code for the cell line from that donor, and a code for any subclones. So from this name, which is really quite short, because the other thing you've got to consider is people need to write this on 6-well plates and flasks, etc. And what happens if you've got a big long name describing all the mutations in this cell line? People shorten it, and then you end up losing track of what's going on. So it's a reasonably short name that actually tells you a lot of information. So it's a very good system. So the other thing, which vials to use and what labels? So Mark touched on labels as well. So again, might seem like quite a dry topic, but we had to be sure that the vials we were using would fit in our cryopreservation systems at the central facility, but could they also fit in the automated cryopreservation system at the mirror facility at Fraunhofer IBMT? And also, would they work at ECAC? Would they work in shipping systems? So the vial, we had to get the vial right, and then we had to get the label right, and we did a lot of work at the early early in the project with IBMT around labels. And we had labels that you put them on the vial, they wrap all the way around and obscure some of the data. Ones where, if your fingernail caught the writing, it came off. Ones where you took the vial at the freezer and the label just fell off of it. And it turned out we ended up with quite a good label that had none of those problems. And this shows you the components of also what information we decided should go on the label. So we have the cell line name, the batch reference. Every single vial has a specific unique ID that's also tied into the vial-specific biosamples ID assigned by EBI. So from that, which is also in the 2D barcode. So from that 2D barcode and that biosamples ID, you can find out which vial this was, from which batch, from which cell line, from which fibroblast culture, from which donor. And it's all linked up. And of course the catalog number at ECAC. Training. So again, training, not necessarily, in terms of a challenge, training, it was really about one of the things that we knew we had to get right, both upstream for depositors around how do you deposit cell lines, so that admin process, but then also how can we inform people of the standardized processes of the bank to encourage those to be adopted. And then downstream for users, so how can we ensure that when somebody orders a cell line that they're successful with it? How can we make sure that that cell line, they have the best chance of recovering that line and it grows well in their lab? And many of the people who have been accessing the lines have not used IPS before, so it needs to be as easy as possible. So we've had a lot of training workshops where we discussed various processes and how to harmonize them. Culture manuals and guidance documents are available on the EBiSC website, as well as a series of really good training videos covering thawing of cells, passaging, feeding, cryopreservation, etc. So I'd encourage you to take a look. Okay, so QC have been touched on already, and I think the first thing I want to talk about is just how did we select the QC tests that were appropriate. So you could throw the kitchen sink at it and have many complex analyses, but in the context of a large-scale bank, you can't really do that. So it needs to be tests which you can rely on to be giving you robust characterization of the cell lines, as well as absence of microbiology, but it needs to be affordable, reliable, quick to do as much as possible. And we were, I guess, kind of looking away, so we initially built that on the basis of activity that the testing we already employed at Roslin Cell Sciences, but also with the UK Stem Cell Bank, and then getting the input from industry partners around what their requirements would be. So no cell line can really go into these corporate entities without having been tested for the absence of viral pathogens, for example. So what were those panels of pathogens that were appropriate? And then thinking about international distribution as well is really essential. So again, I've got a couple of examples I'll come on to in a minute. So as well as choosing the QC tests, and I've referenced another paper here, which is from 2009, which is a good foundation if you want to have a look for guidance on stem cell banking standards. And there's a clinical points to consider variant as well that came out just 2 or 3 years ago. So as well as selecting the tests, we also need to think about the acceptance criteria and how to apply that for these tests. So there's 2 groups, and if you have a look at any of the EBiSC certificates of analysis, it's split into, well, there's data set actually from depositor data, then there's batch release QC, so criteria which are pass-fail criteria, for example, absence of mycoplasma, sterility, pathogens, identity. And then tests which are really informational tests. So, for example, surface marker profiles is to a certain extent considered in that way, and I've got some examples in this table. So identity being the first one. So we had a fair amount, in fact, not many labs who are making iPSCs do an STR profile for identity. But what they might do is a SNP array or something similar, because you get more data for your money, so it's worthwhile to do that, and you can look at identity. But for us, from a large-scale bank processing hundreds of lines, that becomes a bit of a problem because it's more expensive. There's a larger data set that has to be stored. You have to have trained staff who know how to analyze that data. And it's also thinking of the user. Not everybody has the ability to replicate that type of testing. So STR profiles are cheaper, smaller data set, still give you a good forensic fingerprint of the line, and they're easier for users to implement in their own labs. A lot of debate on carriology testing and G-banding and SNP, etc., which is better, and not necessarily going to have that debate now, but we had used G-banding quite a lot, and had looked at SNP arrays as well. Obviously there's a lot of pros and cons with each. But thinking again about acceptance criteria in this area, so for example, even to the extent of finding an extra chromosome, it might not be what you were wanting in your cell line, but it's not to say that that's still not a valuable line and could be included in the bank. So that's, you know, in terms of the difference between release criteria and informational testing. And then more basic tests like recovery on thaw. So Mark already talked about understanding how cells should perform when you thaw them, and that's something that we did in the bank in terms of recording data around how the cells look when they thaw, how do they look after 24 hours, after 48 hours, and how soon should you expect them to grow to confluency. So even these more fundamental measures are really quite important. And then surface marker profiles as informational tests. So if you have an iPSC from a Parkinson's patient, for example, and you're making dopaminergic neurons, and you're really that bothered that SSEA1 is at 20% rather than 1%. So long as that profile is stable over time and it's performing as you'd expect. Okay, storage and distribution. So again, I think actually within the project, everybody did this well. So not so much a challenge, but actually I've kept this slide in because I think it's something that quite often people might overlook, but it's actually really important to make sure that, especially from a bank perspective, that you have good integrity of your cryopreservation systems. So for that, we had some redundancy at the central facility around how we store our cells and backups, but also storing some of the vials at Fraunhofer IBMT mirror facility, and then at ECAC gives us even more redundancy. And we looked at, and Julia's going to talk later about automated cold chain systems, which I think are part of the future. But that was, I kept that in just as a point of importance. And then the other challenge was thinking about the customers and the users. So you have to remember that we're not just shipping out a vial. So as a bank, you need to think about some of the things I've just mentioned already. Getting QC data to people, certificates of analysis, encouraging them to use standardized protocols and having those available. Shipping around the world, are they classified as GMOs in certain countries? Yes and no. And how do you help people to understand that for iPSCs? And then how do you provide them under a structured legal system so that the people understand what freedom to operate they've got and how they can use the cells? So we did that by developing user guidelines and protocols, and Work Package 4 developed legal agreements. But pulling that all together and presenting it to users, it was a fair challenge in the project. Okay. So in summary, don't underestimate the challenge with ethics and consent. That is really one of the, I'd say it's probably the biggest challenge we had in the whole project from the central facility perspective. I think it's something that is being, I think we've done a really good job of developing templates to use in the future, and we actually use those templates in the project. They're very clear. Obtaining existing cell line data can be challenging because you're using up somebody's time that they could be doing something else with. Essential is standardization of processes for cell culture, but also QC, and getting the right balance of QC. So again, in the context of large-scale stem cell banking, is getting the right balance. And then don't forget that it will be complex in terms of both scheduling the cell culture and monitoring that, but then also all the data management as well. And you need to plan ahead for how you're going to provide data to users, because that is the thing that's going to encourage them to actually access the cells. Okay. And finally, just in terms of thinking about future developments and things that might impact large-scale stem cell banking in the future, again, consent, top of the list. So making sure that it's clear that as many cells as possible have the right consent in place. And then automation, so Work Package 3 in the project looked at automation, and I think there was a fair amount of really good developments looking at how that can impact for a bank. Processing more cell lines and larger quantities of cell lines. Cryopreservation cold chain is right from the point you start cooling those cells down to the point that you're thawing them again, making sure that that is as robust as possible. Gene-edited cell lines goes without saying, they are now part of the bank and there'll be more of them. Whole genome sequencing, talking to somebody the other day, was talking about a new platform which is bringing that down to $100 to $200 per sample. I mean, that is just going to happen. And how will that change QC? How will that change how we select cell lines and understand how we use them? I think Orla is going to talk a little about rapid pluripotency assessments soon. I think being able to differentiate the cells in vitro in a quick way and understand how they perform would be a huge benefit for this sort of banking where you've got many, many cell lines. And then lastly, user feedback and data sharing. So something, again, Mark touched on. Thinking about this in a context a bit like on Amazon when you have somebody reviewing a product, it would be great if we could encourage more and more people to feed back and say, yeah, I accessed this cell line and I made cardiomyocytes with it, here's the protocol, or something similar will just help people understand that this cell line is going to work for me. Okay, so if you're thinking of starting a large-scale stem cell bank, then those are some of the challenges. Good luck, and but there's plenty of guidance out there for you. Yeah.
Okay, thanks, Kevin. Do we have questions?
So do you actually freeze down clones or colonies? And the second question is, do you check each of those colonies? If it's a patient line with a monogenetic disease, do you check each clone for the mutation, or do you assume it's there?
Yeah, so do we freeze down single cells or colonies? Yeah, was the first part. So, so actually we tended initially to do whatever the depositor had done in the initially with the cell line, but as we adapted them into the standardized culture conditions, it was all done more as colonies.
Right.
Yeah. And in terms of the confirmation of any genetic lesion that was there, we hadn't budgeted significantly for that in the project, so it's limited in terms of what's been done. Some of that has been done and some has not. So it's variable in terms of the data that's there in the catalogue, but that's also, we as much as possible tried to gather that information from the clinical data from the original donor, so at least we knew exactly what to expect. But that's variable in terms of, and that's purely down to budget.
I make the point because some individuals have turned out to be mosaic. So we can get from a single individual healthy clones and mutated clones. So nobody knows how much mosaicism there is in the general population, but it could be more common than people think.
Yeah, I think that would be a really interesting thing to try and do on a larger scale, is to understand that a bit more. We've seen a bit of that, and especially even with more simple data like doing the STR testing. So we recently had a cell line where we had a triallelic on multiple alleles for one sample, quite unusual. So.